Okay, let's look at how to do some problems when you have solution molarities and you're trying to do stoichiometry. So this one is silver nitrate plus barium hydroxide. So the first thing that you're going to need is to have a balanced chemical equation. So anyway, we'll start off with writing the formula for silver nitrate. All right, that's going to be a solution. So we'll put aqueous plus barium hydroxide, and that's also going to be aqueous. So what's going to happen is the barium will go with the nitrate, but barium is positive 2, so you need 2 nitrates, and then you're going to get silver hydroxide. Now, if you remember, all nitrates are always aqueous, so put aqueous there, so the precipitate must be silver hydroxide. Okay, then we got to balance the equation, so we got 2 hydroxides here, so we're going to put a 2 there. That makes me have a 2 over here with the silver. Okay, so then the next thing that you need to do is try to figure out which one is the limiting reagent. So just by eyeballing it, I can't really tell. So what I'm going to do is I'm going to start one problem here, and I'm going to start with 31.9 milliliters of the silver nitrate. And what I'm going to do is I'm going to see how many moles that is. Okay, so whenever you have a volume, if you multiply it times the molarity in the next box over, 0.90 capital M means 0.90 moles of silver nitrate for every 1,000 milliliters. I had to put milliliters down here because I got milliliters over here. If this was liters here, I would write 1 liter here. Because remember, molarity is moles per liter. Okay, so if I do that math problem right now, that's going to tell me how many moles of silver nitrate. So I'm going to do the math. So 31.9 times 0.9 divided by 1,000. I'm just going to write that number up here for just 1 second. That gives me 0.0287 moles of silver nitrate. Now, I'm going to do the same thing for the barium hydroxide. And so let's see here. So anyway, I'm going to start off with 25.4 milliliters of barium hydroxide. And then the molarity is 0.75 moles over 1 liter. Or I got to do 1,000 milliliters because it's in milliliters over there. And this is for the barium hydroxide. So if I do that, the answer I get is, I'm just going to write it down here for a minute. So if I take 25.4 times 0.75 divided by 1,000, that gives you 0.01905 if I don't round off too much. Okay, so anyway, I have these in moles, and then you can see that there's for every 2 moles of silver nitrate, according to the equation, you need 1 mole of barium hydroxide. So if you were to look at that and you try this, so if you just think about this 0.01905, you can kind of do a math problem. That's the barium hydroxide. That's how many moles you have of it. But what you can do is you can say for every 1 mole of barium hydroxide, you need 2 moles of silver nitrate. And by doing the math of that, you get you would need 0.0381 moles of silver nitrate. And if you look, how many moles do you have of silver nitrate? Well, you don't have 0.0381. So that shows that the silver nitrate is limiting. All right, so what you want to do is you want to use the limiting reagent. And so we're going to work with the silver nitrate. We don't need to do anything else with the barium one right now. All right, so we're just going to keep going with this problem here. All right, So we've just, if we do the math right here, we've converted to moles of silver nitrate, but I'm just going to keep going here. And so then if I have moles up here, I need to put moles down here. And so it's going to be the mole ratio. So 2 moles of silver nitrate will make 2 moles of the precipitate silver hydroxide. And then for every 1 mole of silver hydroxide, the molar mass is around 124.86 grams of silver hydroxide. And if you do the math there, you would get 3.58 grams of silver hydroxide. Now, in the old days of chemistry, we used to just tell you to do 2 problems and see which one makes the least. Now, you could do that, or you could do this mole thing that I did right here to figure out which one's limiting and just do that problem. You can do it either way. I could continue this problem and see what I get, but I think it's just easier to do or quicker to do the mole thing. Okay, now the problem, how many milliliters of excess reagent is left over? Well, we know the silver nitrate is the limiting reagent. So what you can do is you can just start with the limiting reagent, and we know that 31.9 milliliters times 0.9 moles divided by 1,000, we already did that. That's going to be 0.0287 moles of silver nitrate. Now that's the limiting reagent, but it wants to know how much excess is left over. So I know if every last drop of this silver nitrate reacts, or every last mole, I'm going to calculate how many milliliters of barium hydroxide that would take. So I'm already at moles, so I'm going to do the mole ratio. And the mole ratio is for every 2 moles of silver nitrate, you need 1 mole of barium hydroxide. Now, the next thing is we don't want to go to grams of barium hydroxide because it's asking for how many milliliters. So what we can do is if we stop the problem right there, we're in moles. So we can use the molarity of barium hydroxide to get the milliliters. So I know the molarity is 0.75 molar. So that's 0.75 moles of barium hydroxide for every 1,000 milliliters of barium hydroxide. And if I do the math, that's going to tell me that 19.1 milliliters of barium hydroxide is going to be used up. Okay, so what we just calculated here is if all the silver nitrate reacts, because we know that's the limiting reagent from the problem above, it's going to use 19.1 milliliters of barium hydroxide. But if you read the problem, there's 25.4 milliliters available. So how much is left over? You would take 25.4 milliliters of the barium hydroxide, subtract 19.1 milliliters, and you end up getting 6.3 milliliters is left over. All right, that's how to do a problem like that, so I hope you can do it.